Hi, so we are going to solve a problem. So here is the problem. So this is implement a stack in which you can get min element in O of 1 time and O of 1 space. So we have to implement a stack in which we have to get an element in O of 1 time and O of 1 space. So whenever we'll pop a number, pop an element, so the current stack, whatever elements are available, it should return the minimum element from that. So this one is a bit tricky because we have to do in O of 1 time and O of 1 space. So first of all, I'm going to explain how are we gonna do this. So there are few rules for this one. So first of all, we'll discuss about the push. So for push, so first of all, we'll see if a stack is empty. So if stack is empty, then we simply insert the number or the element, whatever. So we'll say that X. So we'll insert X and make this current, which is make this minimum element, because this is the only number, so this will be assigned minimum element. Okay. Next, if stack is not empty, so it means it already have some elements. So in that case, we have to do few things. So first of all, we'll compare X with the minimum element. Okay. So while comparing X with minimum element, two things can happen. So first of all, we'll write first case. So when X will be greater than or equal to minimum element. So in this case, if X is greater than minimum element, then we don't have to do anything, we simply insert X. Okay. Now the other case is if X is less than minimum element. Okay. Then in this case, what we are going to do, we'll insert 2X minus minimum element and assign, we'll insert this one in the stack, and now the minimum element will be X. Okay. So this we have to remember, like we have to do in case if it's smaller. Now we'll discuss about the pop. So for pop, first of all, we'll remove element from top. And why did I top? And we'll assign it as Y, like Y. Okay. So while popping, so it means there are already elements, and we don't know, like it could be smaller, greater. So first of all, we'll check if Y is greater than or equal to minimum element. So if it is greater, we'll just remove Y, we just pop Y, and minimum element is still Y. X. Minimum element is still whatever the minimum element was. is minimum element, whatever it was previously. Now if y is less than minimum element, so it means we are removing the current minimum element. In this case, if y is less than, so it means that this one y, that y is the current minimum element. So if we'll remove that one, so we have to provide the next minimum element from the current stack. So in that case, what we are gonna do, we'll simply do some calculation. Min element will be equal to 2 into min element minus y. So this will give the, so we'll pop that current y, and now we'll set the minimum element as 2 times minimum element minus y. Okay, so these are few rules to solve this problem. Now we'll see if it works. So let's take an example. So suppose I have these numbers 18, 19, 29, 15, 16. Okay, so first of all I'll create a stack. Okay, so the first element is 18. So according to this rule, the stack is empty and we don't have any elements. So the first element which we insert, which is this one x, it will make this one as minimum element. So 18 will push 18 into the stack and minimum element is 18. Okay. Now next is 19. So we'll compare if x is greater than or equal to. So 19 is greater than minimum element, so it means x is greater than minimum element. So we'll follow this rule. We simply insert x, so which is 19. Now next is 29. Now this x equal to 29. Now we'll compare. 29 is greater than minimum element. Yes. So 29 is greater than minimum element. So we'll simply insert 29. Now x is 15. We'll check 15 is greater than minimum element. No. 15 is less than minimum element. So now we have to go here and use this one. So when x is smaller than minimum element, we'll have to insert this one into the stack. So what are we gonna insert? 2 times x minus min element. So 2 times 15 minus minimum element is 18. So 30 minus 18 equal to 12. So we are gonna push 12 into the minimum element, and minimum element is x. So now minimum element is 15. Now next is x is 16. So 16 is greater than minimum element. So we don't have to do anything. We'll simply push 16. So this is how our stack will look like. Now we'll have to do the pop. So for pop, I'm again gonna draw the same thing which we had. It was 16, 12, 29, 19 and 18. Okay, so minimum element was 15. So while popping, again we have to check from the rule if it is greater, if y, so first of all the first y is 16, sorry. So y is greater than min element. We don't have to do anything. Min element is still 15, and we'll just pop y, remove. Next is 12. Now y is 12, and since this is a small stack and we are doing things manually, so we know that 12 came from 15. So if we remove this, we have to update another minimum element. So y is less than min element here. So we are just gonna, what was the formula? We have to check the formula. So this is the formula. So now the min element is 2 times min element minus y. So 2 times min element is 12. Sorry, min element is 15. 15 minus y is 12. So it's 30 minus 12, which is equal to 18. So we'll remove 12, and now the current minimum element is 18. Now next is 29. Now y equal to 29. So even if this one y is greater than min element, it doesn't matter, we simply remove and minimum element is still 18. So that's how we know that this pop is working. So now to write it in the code. Okay, so now we'll write the code. So first of all, I'm gonna create a class, public class myStack, then public stack as, we'll take a stack as, and then minimum element, public int minimum element. Okay, now we will create a constructor, public myStack as equal to new stack. I will write minimum element function, public void get min, and then we'll see if the count of a stack, if s dot count equal to 0, if there is no element in the stack, we'll simply print stack is empty. Okay, else what we are gonna do, we'll print the minimum element in stack, whatever the minimum element is. So console right line minimum element in the stack is min element. Okay, so this was the function for min element. Now we'll write for peak. Okay, so for peak we'll write public void peak. Now if s dot count equal to 0, so what we have to do, we'll have to print stack is empty. And then we'll just return it from here because we don't need to go further. And now if there is some element, then